Hello, welcome to a Sea Change, Integrating Ocean Acidification and Inquiry for the Transformative Education for Climate Action Conference. The work that I'm going to share today was done by myself, Corin Sloan, assistant professor at California State University, Monterey Bay, and two phenomenal undergraduate students, Isabel Gutierrez, who graduated this spring with a degree in biology and a teaching concentration, and Madeline Church, who will graduate in fall 2019, also with a degree in biology and a teaching concentration. The goal of this project is to think about how to connect the content, knowledge, and skills from upper division undergraduate courses in STEM from California State University, Monterey Bay, to authentic inquiry experiences in middle school classrooms in Monterey County, specifically targeting 6th grade students, with the goal of thinking about how we can incorporate action and iterative practice and also provide targeted feedback. We're going to be using a pedagogical approach for teacher preparation proposed by Milner-Blotton of model, reflect, research, practice, which is designed to engage teacher candidates with novel pedagogies as students and as future teachers, and to acquire positive attitudes about the value of evidence-based education research in their own practice. Now, notably, these are students who are not actually yet in a credential program. These are individuals who are still completing their Bachelor of Science degree. But when we discuss this approach, they were eager to observe both the modeling of practices and to reflect on those practices, to then engage in research around the practices, and then to actually incorporate those practices themselves. When we think about this approach, it actually has 4 stages. The first stage is modeling. This is where future teachers experience research-based pedagogy, ideally in the classroom. The second is reflect. This is where future teachers reflect on their experiences as learners and as future teachers. Research, where future teachers discuss the foundation of this pedagogy, the evidence behind that practice, and then the actual practice itself. This is where they incorporate the pedagogy into their own teaching. We chose a sea of change, integrating ocean acidification and inquiry, so that we could pilot inquiry curriculum for 6th graders, engaging students with the concepts of pH, acidity and basicity, and ocean acidification, recognizing the peril presently facing shellfish and coral from ocean acidification. We wanted to think about an authentic context in which to ground our problem of inquiry. We also recognize that there's value in aligning this experience with the next generation science standards as adopted by the state of California, specifically because the individuals who are engaging in this iterative practice will in fact be going into classrooms where this is the very content that they will be teaching. And so we chose to focus on middle school physical science, matter and its interactions, whereby students analyze and interpret data on the properties of substances before and after the substances interact to determine if a chemical reaction has occurred. There are 3 dimensions to the next generation science standards: science and engineering practices, the disciplinary core ideas, and cross-cutting concepts. So throughout the lesson plan, the implementation of the lesson, and reflection on that lesson, there was a focus on students analyzing and interpreting data. The disciplinary core ideas are physical sciences, structure and properties of matter, as well as chemical reactions. And the cross-cutting concepts are patterns, specifically macroscopic patterns that are related to the nature of microscopic and atomic level structure. We also wanted to incorporate environmental principles and concepts also adopted by the state of California. There are 5 environmental principles. The first principle is that people depend on natural systems. The second principle is that people influence natural systems. The third principle is that natural systems change in ways that people benefit from and can influence. The fourth principle is that there are no permanent or impermeable boundaries that prevent matter from flowing between systems. And the fifth principle is that decisions affecting resources and natural systems are complex and involve many factors. We recognize that as we developed our lesson inquiry, targeting all of these principles would be ineffective. And so we chose to ground the work in the first principle, that people depend on natural systems, with the hope that students would recognize the value of protecting shellfish and coral as part of a food system that feeds the people of this planet, as well as part of an ecosystem where these are components that are critical to the survival of life in the ocean. When we contemplated a sea of change, integrating ocean acidification and inquiry, one of the things that we recognized is that it would be important to have a conversation with the future teachers about their own understanding of ocean acidification. And so we walked through an understanding of atmospheric carbon dioxide, how that becomes dissolved carbon dioxide in ocean water, and how that can generate carbonic acid, and how there is a system of equilibrium between the carbonic acid, bicarbonate ions, hydrogen ions, and carbonate ions. And that as we shift towards more acidic or lower pH in our oceans, there is an increased generation of hydrogen ions and carbonate ions, shifting away from the bicarbonate ions themselves. And what was interesting about this is that each of the future teacher candidates that we worked with had seen ocean acidification in the context of their upper division biology electives, but had not yet thought about how they were going to incorporate teaching this if they were to step into a middle school science classroom. And so we took time to ground in what our learning objectives would be, what ideally we hoped students would walk away from the lesson understanding. And so as part of the conversation with these future teacher candidates, these are the pieces of knowledge that we surfaced that they thought would be critical for students to walk away understanding. That oceans absorb approximately a quarter of the carbon dioxide humans produce every year. When carbon dioxide mixes with the water, it forms carbonic acid. Increased carbonic acid leads to the depletion of carbonate ions. That carbonate ions are an essential component of minerals vital for building seashells. Carbonate ions become less abundant in a more acidic ocean. The current rate in acidity change is about 50 times faster than any known historical change. With reduced availability of carbonate ions, shellfish struggle to build shells and skeletons. The first component of developing this lesson was modeling. And so the future teachers observed a teacher include the engaged lesson, which accessed prior knowledge in the classroom. The first thing the teacher did was ask, what do we think we know about pH, surfacing students' prior knowledge. As the lesson proceeded, the teacher then facilitated students answering the following questions. What are we learning? What is our evidence? What are we wondering? Ultimately with the goal of gauging what scientific principles help us to explain our knowledge or connect to our evidence. The first reflection that the future teacher candidates engaged in was around accessing prior knowledge. Candidate 1 said, I forget that students have not yet had many science experiences in the classroom, but they are surrounded by chemicals in their home. We can help them see that they encounter acids and bases every day. Candidate 2 observed, maybe they already know about acids and bases, but not the academic language for them. For example, so many students knew that lemon juice was sour or that cleaning solutions were slimy. Students or future teachers then engaged in research, specifically around accessing prior knowledge. They surfaced 4 critical pieces of primary literature. The first piece of primary literature cites Marzano. What students already know about the content is one of the strongest indicators of how well they will learn new information relative to that content. Also from Kluel, sometimes students don't access their background knowledge because they never think that it's important. But the National Research Council states, all learning involves transfer from previous experiences. Even initial learning involves transfer that is based on previous experiences and prior knowledge. And this observation is key. Students gain a better understanding of the content because they're able to use what they already know, from Echeverria, Vogt, and Short. We then discussed modeling the explore component. This is where students construct knowledge and skills through inquiry. During this modeling session, the teacher facilitated students testing lemon juice, baking soda, milk, vinegar, soda, Windex, and water using the indicator red cabbage to observe color changes as a result of the indicator. The reflection from the future teacher candidates around the explore constructing knowledge and skills through inquiry included the following observations. Candidate 1, I wonder if they, the students, realize that the color of the liquid can influence the color they observe, and thus their outcome. For example, a blue liquid may have dye in it and not actually be basic. This could create a misconception. Candidate 2, we could ask questions to help students wrestle with the misconception as they are exploring, maybe point out 2 examples and ask the difference between the 2. Candidate 1, I wonder if students realize that concentration influences pH. Candidate 2, I think students are still building knowledge of what a scale is. They recognize the intensity and color having meaning, but we might need to facilitate students creating a scale. The future teacher candidates then engaged in research around inquiry learning as a result of the explore or constructing knowledge. They identified 3 critical articles, specifically Bradford, Brown, Cocking, Barron and Darling Hammond, and Sawyer, which identified that approaches to inquiry learning support students in deep learning. As the students had not yet had awareness of what deep learning comprised, they pulled out this particular set of descriptions of deep learning. That deep learning requires that learners relate new ideas and concepts to previous knowledge and experience, which ties to their accessing prior knowledge. That deep learning requires that learners integrate their knowledge into interrelated conceptual systems. That deep learning requires that learners look for patterns and underlying principles. And that deep learning requires that learners evaluate new ideas and relate them to conclusions. Deep learning requires that learners understand the process of dialogue through which knowledge is created and can examine the logic of an argument critically. And that deep learning requires that learners reflect on their own understanding and their own process of learning. Recognizing that perhaps there was more to understand around inquiry or the process of exploration, the future teachers also read an article from Johnson and Adams that stated engaging multidisciplinary approaches to teaching and learning encourages learners to solve real-world problems. And finally, an article from Hattie that stated inquiry-based teaching is the art of developing challenging situations in which students are asked to observe and question phenomena, pose explanations of what they observe. The actual practice, then, of accessing prior knowledge and exploring. The future teacher candidates observe the students create their own relative pH scale. What you see here in 4 milliliter scintillation vials are some of the colors that students observed when they treated household chemicals with the red cabbage indicator solution. The goal of this explorer was for students to be able to create a relative scale so that they could observe changes in pH depending upon which household chemical they were testing. However, the future teacher candidates also recognized that perhaps the color scale itself might need some additional refinement, as students sometimes struggled with what was acidic and basic initially using their tested household chemicals. And so the teacher candidates proposed using pH strips as a secondary way of confirming the knowledge that students were constructing. And so they used Hydrion pH 1 to 12 to confirm the scale that the students were creating. They also did subsequent research around this idea of constructing knowledge and skills through inquiry. Specifically, they were intrigued by the idea that you could integrate instruction, where you could provide students opportunities to learn in relevant and stimulating experiences. This was part of the reason why we were trying to think about how to ground critical thinking or problem solving. This is from Stolman et al. From 2012. There was also significant evidence that active engagement is crucial for STEM learning, and this was something that was surfaced in students' own experience in classrooms with sixth grade students. And finally, when a student develops knowledge and skill based around an activity, that the context of that activity is essential to the learning process. What was intriguing about this is that the students had a choice as to whether or not they grounded the instruction for the sixth grade students in a short video around ocean acidification and the problem of pH with respect to the construction of shells for shellfish. Ultimately, they decided that that context was really important for students to learn about pH, because without the context, while the color change would be interesting or perhaps momentarily entertaining for students, without the larger context or the importance of understanding pH change, it was just less relevant for the students' own learning. Finally, one of the teacher candidates subsequently returned with an article from Perzer et al. In 2015 with the following definition: scientific inquiry involves reasoning processes such as analogical reasoning as navigational devices to bridge the gap between a problem and a solution. And it helps wrestle with uncertainty as a starting condition that demands expenditure of cognitive resources. Ultimately, the future teacher candidates decided that the best way to determine whether or not students had an understanding of pH and relative acidity or basicity was for them to conduct an experiment. In fact, ideally for students to design their own experiment. And so they provided cabbage indicator solution, a relative scale of the color change associated with that indicator, and then unknown solutions. The students had all of the tools from the previous inquiry and exploration, all of the household chemicals that they tested, as well as their results. And their goal was to describe a procedure, test 3 unknown solutions, determine their observed pH, and then identify similar solutions from their created scale. The goal being that ultimately students would be able to test whether or not their scale for determining pH was reliable once the identity of those solutions and their respective pH was known. From the practice of this particular skill, the teacher candidates observed students quickly identified patterns, which liquids were similar to liquids they had already tested. They could actually articulate those patterns. Candidate 2, I think using the strips, students were able to create a scale from low pH, very acidic, to high pH, very basic. Candidate 1, when we asked them, the students, if the ocean was a liquid and if they could measure its pH, every group said yes. Candidate 2, students realized that pH is a property they could measure of any liquid. Now, the candidates realized that in order to determine whether or not students connected their inquiry experiences or their explorations with student knowledge, they wanted to see if students could understand that what we've been measuring when we look at pH was in fact a critical piece of evidence in ocean acidification. So they walked students through the process of carbon dioxide from the atmosphere being absorbed by the ocean. And then they talked about how carbon dioxide reacts with the seawater to form carbonic acid. They talked about how hydrogen ions that are released from the formation of carbonic acid could be tested in the ocean. And this is how we would be able to measure ocean acidification. Finally, they engaged the students in claim evidence reasoning. They wanted to see what the students retained, what information stood out to them based on their experience through inquiry. Notably, there were some key pieces of information. Students retained that oceans absorb carbon dioxide, Students retained that carbonate ions build seashells. Students retained that there was some type of acidity change in the ocean, and that shellfish struggle to build shells and skeletons. Intriguingly, this integration of ocean acidification and inquiry did in fact lead to action. At the conclusion of this lesson, many of the 6th grade students asked, how can we replenish carbonate in the ocean? Or how can we reduce the rate of ocean acidification? Is it possible to change policy or law about carbon dioxide and how it gets into the ocean? As a result of their questions, the actual teacher of these 6th grade students agreed to have them engage in an engineering design process where the students would propose solutions for these critical questions. For the future teachers who were engaged in this lesson design process, they were asking critical questions about how to engage students more deeply, how to integrate content knowledge with student experience, and how to raise the profile even further of ocean acidification in their communities. The idea for the title of this talk, A Sea Change, comes from William Shakespeare's The Tempest. Full fathom 5 thy father lies, of his bones are coral made, those are pearls that were his eyes, nothing of him that doth fade, but doth suffer a sea change, into something rich and strange. Sea nymphs hourly ring his knell, ding dong, hark, now I hear them, ding dong bell. Part of this study was to consider that a sea change is a metamorphosis or a transformation. The goal was that these future teacher candidates would engage in a process that allowed them to see pedagogy modeled in the classroom that incorporated authentic context for teaching about ocean acidification and pH, that would allow them to reflect on that process, to take note of and observe what they thought was significant or important about student learning, to then research the actual pedagogy itself that would allow them to have a deeper understanding of what they were trying to bring into the classroom, and then to finally practice, ideally iteratively, bringing that content to students. They were able to do so for 4 different classes. And what was intriguing about this was that each of the students that they had conversations with, originally for their first question of what do you know about pH, said nothing. Students really didn't know about pH. It wasn't something they were familiar with. But by the end of the lesson, students were able to identify the scientific principles associated with pH. They were able to describe a relative scale of acidity to basicity. And most importantly, they were able to articulate why ocean acidification, or a change in pH in the ocean, was a critical issue. And most importantly, they were able to identify actions that they proposed taking to address this critical issue. Thank you very much. This work would not have been possible were it not for the phenomenal references identified by these students and the readings in primary literature that support accessing prior knowledge, inquiry, and exploration, as well as the critical readings associated with teacher preparation and effective STEM education in the classroom. We would also like to thank Professor Cheryl Logan and her lab that currently conducts research on ocean acidification. We would like to thank California State University, Monterey Bay, as well as the school districts of Monterey County, and all of you. Thank you again.